Hi, my name is Paweł Spychalski and today let's talk about 18650 batteries. Why those things? Because they have a very nice features that might be used, it is used, and it's really worth checking them out in the FPV community because they have something that LiPos, the ones we are using everywhere, lack. But before going that, let's take a look at the 18650. What's an 18650? It's an industry standard. I'm not saying this is really a standard because it's complicated like always. The number comes from the dimensions of those thingies. Where the heck did I put my... Oh, here it is. 18 goes for the diameter of the battery. It's 18 millimeters, sometimes slightly more, sometimes slightly less. And the 650 comes from the length of it. I have to be very careful not to short circuit this side and this side because it might just do a nasty stuff. So, as you can see, it's 65 millimeters. So the number 18 is for diameter and the 650 is for length. But another battery. The same? Yeah, more or less the same. But look, this one has a flat positive terminal and this one has a not so flat positive terminal. The third one, you see, also named the 18650, but if you look at it, it's slightly longer from the other one. What the heck is happening over here? Well, like with every industry standard, you can just break the standard from time to time because those really are the industry standard LiPos. Those I'm having here are not so very industrial because they have something that this doesn't have. This one, made by Samsung with the INR type, different story, is something called not protected. It's just a lithium, not LiPo, it's lithium battery without any additional of any kind circuitry. Those two have something special. They, at least, I'm pretty sure this one has, and they wrote that this one has it also. They have the overcharge, over discharge, and the current protection circuitry. Here, over here, maybe you will be able to see this element over here contains small electronics that cuts the connection to the battery when either the discharge current is too high, charge current is too high, or the battery voltage goes below threshold. How much? Depends. Depends on the electronics, of course, but usually it's around 3 or 3.2 volts, and then the circuitry cuts the battery off. Oi, 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 oi. Something like that will not, of course, happen with those unprotected batteries without any protection. Question: which one should you get? For RC hobby and all the FPV thingies, I suggest getting not protected batteries. Why? Because when the current stored in the 18650 will just go lower, the voltage outputted by this thing will also get lower, and probably the electronic you are using has some kind of letting you know that the voltage is down, that the battery will discharge very, very soon. FPV goggles will start to beep. In the OSD you will see that the voltage is very low because, for example, those things can be discharged up to 2.5 volts. I'm not saying you should do it, but they should survive even down to 2.5 volts. This, with a LiPo battery discharged to 2.5 volts, probably wasted. This one should recover and live very, very nicely. Non-protected battery will give you some kind of information that the battery is going down, it's over discharging, and you should land or change them. Those protected, you miss the voltage information, bam, gone. There might be still some current left in there, but electronics cuts the battery off, and for example, if you had this on the aeroplane, you're going down because the aeroplane has no voltage at all, zero. The electronic cut everything, or the FPV goggles go down, or you just probably lost your model. But if you are using this in some kind of, let's say, battery operated electronics that's supposed to stay somewhere for months, go with protected. Or for example, for a flashlight, go with, where's the flashlight I had over here? Fuck, I had to, oh man. Oh yeah, the flashlight, because for the flashlight, even if this will go down, probably nothing really hard will happen. So for this kind of purposes, choose protected. For anywhere, anything with the FPV community, FPV hobby, go with unprotected lithium batteries. Why? What can I do with the lithium batteries? You can, for example, use them to power your FPV goggles. Yeah, 3 amp hours should really give plenty of hours of operation. Or you can connect them together, maybe not. You should not mix protected, not protected. You can connect them together to get one 4S or 5S or 6S battery pack and fly. Why? Because like I said, those thingies has something special. They really are well suited for the long range operations. Why? Because the electric charge density is much higher on the LiPos, and then can be discharged to much lower values. Those, like I said a few minutes ago, probably even down to 2.5 volts, and they should survive the treatment. This, no. But let me show you why this is sometimes better than this one. Let me find the scale and let's compute something that the power density inside of those and those batteries. How to do it? We're gonna divide the watt hours power stored in the battery by the weight of this. Let me turn the thing. This one weighs 180 grams. It's the top-notch LiPo 4S 1.55 amp hours, and what's the voltage, nominal voltage? 3.7 times 4. Hell, what's the 3.7 times 4, 14.8 volts. We have more data, and this is Lithium 18650. 1S, of course it's only 1S. So it weighs, how much it weighs? 52 grams. Oh, I forgot to type the 180 grams. It weighs 52 grams and has the voltage of 3.7 volts and holds the current of 3 amp hours. So this one is almost 4 times lighter, holds twice as much amp hours, and has 1/4 of the electricity stored inside. So let's compute the watt hours, the total power that can be stored. So this will be voltage, so 14.8 times 1.55, I have to use this burger, times 1.55, that's, let's say, 23 watt hours, and let's divide it by the weight. The weight was 180. Of course, we had to subtract some for the weight of the plug and the second plug and the wire. So let's say it weighs, how much? 165 grams of the only of the batteries. So 23 divided by the 165, that gives us, really? What the hell am I? What hours per gram? That gives us 0.14 watt hours per gram. That much. This one, let's compute. So 3.7 times 3, not 3.7, times 3, because this lithium battery holds about 3 amp hours. So this is 3.7 times 3, that's 11.1, and weighs 52 grams, so divide by 52, 0.21. 1/3 less weight than the LiPo. You see where I'm going? You will get much more charge, much more current with a much less weight. Okay, there will be some size penalty, but this is oh wow. With the same weight, you can get 1/3 of the more power into the battery pack, do-it-yourself battery pack, made only with 18650 lithium batteries. Worth it? Probably worth it. Right now I'm just during my vacation or before my vacation, so I did not finish this project yet. But for me the goal is to have the, I did not decide it yet, the 4S, 1S or 2S lithium battery, pack battery made from 800, 650, used for the endurance long range flights. Oh, but I forgot to mention, those buggers have some problems. This is rated at 75 C, so 75 times 10. This one can be discharged at more than 100 amps without the risk of destroying this immediately or getting or catching fire during the discharge. With those babies, no. Top-notch batteries with the, let's say, INR nickel, what's the, I always forget, those are the lithium magnesium nickel, most of the they are labeled INR. This, for example, Samsung is rated for 20 amps only. That's less than 10 C, it's 7 and something C, comparing to the 75. Come on. The best Sony Canyon is rated at 30 amps discharge. So this is only around 10 C. 10, 75. Use it for racing? No way, no way, no way. Those connected in serial only without going parallel to increase the max current, this is rather only usable on the aeroplanes when you remember to really be very gentle on the throttle, because you can destroy your LiPo, like, not LiPo, lithium, almost immediately. On the multi-rotors, no, rather not. Even the cruiser might easily go above 20 amps, and then if you have to like make those in parallel, it's getting complicated. Doable, but really complicated. For multi-rotors, go rather with well-tested LiPos. For the long-range airplanes, or after connecting them in parallel, you might try using them or multi-rotors, but let's say it's still under experiments. Oh, one more thing. In China, you can get those thingies like for 1/3, 1/10 of the price of something got not from China, some different companies and stuff like that. Rule of thumb: this battery should weigh, the lithium 18650 should weigh around 50 grams and hold around 3 amp hours. If someone is trying to sell you a cell that has like 6 amp hours or 10 amp hours, he's selling you shit. If he's trying to sell you something that weighs below 40 something grams, like 20, 30, he's selling you crap, total Chineseium. Don't even try, because you will regret it. Because, come on, really, honestly, what's the chance that some no-name company in China that nobody ever heard is making cheaper, better and stronger batteries than the top-notch, the best manufacturers in the world, like Panasonic, Samsung or Sony? Really, come on, what's the chance of this thing happening? Okay, our 15 minutes for today is over. This is all about the 18650 theory and introduction to it for today. Until the next one. Ciao, ciao.